Hello everyone and welcome back. So in our previous lecture we learned some theorems or properties on Laplace transformation. Now here in this particular lecture we are going to learn some standard results and also see how to prove those, or also you can see that formulas for Laplace transformation. Okay, so let's get started. So what is the first result or formula? So Laplace transformation of 1 is equals to how much? 1 by s, and here s is greater than 0. Okay, so how to get this? So we know that what is Laplace transformation of f of t? Laplace transformation of f of t is 0 to infinity e to the power minus st, and then what? F of t dt. And this we can write like f of what? S. Now here you see Laplace transformation of 1. So here for this particular property or result, f of t is how much? 1. So here f of t is equals to what? 1. So let us put it here. And then what is Laplace transformation of 1? So is 0 to infinity e to the power minus st, और यहाँ पे जो f of t था, in place of f of t हमें भी क्या लिखना है? 1. So 1 dt. So अभी इसको सिंपली इंटीग्रेट करना है. So what this is of the form e to the power minus mx. So integration is e to the power minus st by minus s between the limit what? 0 to infinity. So you can take my 1 by minus s outside. So then we have to put the limit here 0 to infinity. Okay, so minus 1 by s. Now first we have to put upper limit in place of what? T. So if we put infinity, this is of the form e to the power minus infinity, and e to the power minus infinity is how much? 0. Okay, then we put the lower limit 0. So in place of t, if we put 0, this is e to the power 0. Anything to the power 0 is how much? 1. So minus minus plus, how much it is? 1 by s. Okay, so it's simple, 1 by s. So this is our first result or first formula. Laplace transformation of 1 is how much? 1 by s. So here s is greater than 0. Why s is greater than 0? Otherwise, if it is 0, okay, then something by 0 is undefined. And then for other negative values, this is also not defined. Okay, now let us go to result number 2 or formula number 2. So here what we get? Laplace transformation of t is equals to, it is 1 by s square. Now see, just now we have Laplace transformation of 1. Now we have Laplace transformation of t. So Laplace transformation of t, so it will be how much? 0 to infinity e to the power minus st. अभी जो कैपिटल f of t था, in place of capital F of t हमें अभी क्या बैठाना है? t बैठाना है. So t into dt. Now how will integrate this? Integration by parts. Okay, so here t is first function because it's algebraic and this is exponential. So ये क्या होगा? ये second function होगा. So what is the formula? First function into integration second. So e to the power minus st का जो integration है वो ये आएगा between the limit 0 to infinity, then minus 0 to infinity ddt of first. अभी पहला जो t है उसका differentiation क्या है? 1. Then integration second. Okay, now the first integration is very interesting. You see, if you put infinity in place of t, e to the power minus infinity is 0. So this part will become 0. And when you put 0, then this part will become 0. So when you put upper limit, the second term becomes 0. When you put the lower limit, then the first term will become 0. So ultimately, ये जो पूरा term है ये 0 हो जाएगा. So it's 0 minus 0. तो यहाँ पे minus minus plus, then s को हम लोग बाहर लाएंगे. So what we have? 0 to infinity e to the power minus st dt. Okay, so again we are getting e to the power minus st dt जो यहाँ पे था, e to the power minus st dt. So let us integrate it. So this is how much? E to the power minus st by minus s between the limit 0 to infinity. Okay, so after taking this minus s outside, we will get 1 by s square. If we put infinity 0 and if we put 0, then it is 1. So again minus minus plus 1 by kitna? S square. So बहुत ही simple है. Okay, so this is our property number 2. We can generalize this. Suppose this is t, no? So if it is t square, t cube, t to the power 4 or t to the power n, then what we'll get? So if we generalize it, then we'll get, suppose third property, Laplace transformation of t to the power n. Okay, if it is t to the power n, then what we'll get? We'll get n factorial divided by s to the power n plus 1. This will get. Okay, so Laplace transformation of t to the power n. This is our f of t, okay? So it will be 0 to infinity e to the power minus st. In place of f of t, we are going to write t to the power n dt. Okay, t to the power n dt. So now, this is t to the power n. So if we bipart it, then what we'll get after biparting? So here this is our first function and this is our second function. So first function into integration second between the limit 0 to infinity, then minus dt of first. तो t to the power n का जो differentiation है क्या आएगा? n into t to the power n minus 1 integration second, simple integration dt. Okay. Now again you see, if we in the first part, if we put infinity, this will become 0. If we put 0, then this part will become 0. So ये जो part है ये 0 हो जाएगा. And here you will get what? Minus plus n by s. So let us bring n by s outside. Now what we have, 0 to infinity t to the power n minus 1, then e to the power minus st dt. Okay, e to the power minus st dt. So yeah, minus st dt. So now what we'll get? एक बार इंटीग्रेशन करने के बाद यहाँ पे t to the power n आ गया. So if we integrate it again, so now we'll get what? n minus 2. So like this it will keep continuing, right? So suppose n by s. So if we integrate it, one more term will come out, na? n minus 1 by kitna? S. And then this will become 0 to infinity t to the power how much? n minus 2 e to the power minus st dt. Similarly, okay? So here you see n minus 1. So in the same way, if you keep continuing it, what will get? n minus 1, n minus 2, ऐसे करके finally क्या आएगा एकदम लास्ट में 1. And then यहाँ पे s, each and every term में एक s आएगा. So finally यहाँ पे क्या बचेगा? 0 to infinity. अभी ये आ जाएगा t to the power n minus n. See, if there this is 2, then we get 2s, right? 2s. So if this is n, so यहाँ पे कितना s है? n. So s, so total it will be s to the power n. Then e to the power minus st, what? dt. Now you see, this is from 1 to n. So product of n natural number is what? n factorial. और यहाँ पे कितना s है? तो कैसे हम लोग को मतलब पता चला था? If it is 1, you see, if it is 1, then only 1s. If it is 2, then how many s? S into s square. So since it is n, so here we will get s to the power n. Now t to the power 0, anything to the power 0 is 1. So सिर्फ क्या बचेगा? 0 to infinity e to the power minus st dt. Okay. So let us integrate it, n factorial by s to the power n. So after integration, it is e to the power minus st by minus s between the limit 0 to infinity. Okay. Now let us bring this minus s outside. Now it will be n factorial divided by minus s to the power n plus 1. Okay. And if we put the limit, it's 0 minus 1. So finally this is the answer, n factorial divided by how much? S to the power n plus 1. So this is the Laplace transformation of t to the power n. So this is very important because in number 2 we see Laplace transformation of t, but here it is t to the power in generalized form. So this we can use in many examples. We have to use in many examples. Okay, now let us take another one. Formula 4, Laplace transformation of e to the power at. So ये बहुत ही interesting और बहुत ही मतलब ज़्यादा use होने वाला formula है. Laplace transformation of e to the power at. So this will be 1 by s minus a. ठीक है? तो यहाँ पे जो s है, it should be greater than a. Okay, it should be greater than a. Otherwise it will not be defined. So now here capital F of t जो है वो क्या है? यहाँ पे f of t is e to the power at. So Laplace transformation of e to the power at is equals to what? 0 to infinity e to the power minus st. So in place of f of t हमें क्या लिखना है, e to the power at dt. Okay, so 0 to infinity. So we can take what common, s minus a we can take common, t dt. So ये constant है यहाँ पे, this s minus a is constant. So let us integrate it. So e to the power s minus a into t divided by minus how much, s minus a between the limit 0 to infinity. So ये जो constant है इसको हमें अभी क्या करना है, इसको बाहर लेके जाना है, minus 1 divided by s minus a. So the remaining term is s minus a t between the limit 0 to infinity. Okay, so this is equals to minus 1 by s minus a. लिमिट बैठाने से t यहाँ पे infinity बैठाने से, so again सेम ही होगा 0 minus 1, so minus minus plus, it is s minus. Okay, so this particular formula no, is very very important. Laplace transformation of e to the power at, so it will be 1 divided by s minus a. ठीक है, 1 by s minus a. Now there are some properties related to trigonometric also, like Laplace transformation of cos at. So इसका जो Laplace transformation है वो हमें ये मिलेगा s divided by s square plus a square. और अगर ये sin आएगा Laplace transformation of sin at, so this will be a divided by s square plus a square. Okay, so ये दोनों हम लोग अभी प्रूव करेंगे यहाँ पे. So for to prove this, no, the previous result we have to use here. See, just now what we have, Laplace transformation of e to the power at. क्या था, 1 divided by how much, s minus. Now see, if in place of at, if I write iat, then it will be what, 1 divided by s minus I. I is what, imaginary quantity. Okay, so I should not be in the denominator. So हमें क्या करना है, rationalize करना है, s plus ia, और नीचे क्या आएगा, s minus ia and then s plus ia. ठीक है, so this is equals to s plus ia, and here we will get how much, s square plus a square. Now I think you still remember what is the formula for e to the power ix. Okay, so e to the power ix is how much, cos x plus I sin x. So it will be what, Laplace transformation of 1 will be cos at, then I sin what, at, right? And see on the right hand side, no, you can separate the real and imaginary part. So 1 you will get s divided by s square plus a square, and then I into a divided by what, s square plus a square. So in our last lecture, no, we learned one linear property. So if there are two, suppose this is capital F1 of t, and here C1 is 1, so C1 into F1 of t, and here C2 is I, C2 into capital F2 of t. So what you can write then, cos at plus I into Laplace transformation over sin at by linear property. Right side is again same. Okay, so now if we comparing real and imaginary part, you will get Laplace transformation of cos at is s divided by s square plus a square, and Laplace transformation of what, sin at is nothing but a divided by s square plus a square. So it's very very simple, right? Okay, now let us take one more. So in the same way, no, we can prove for hyperbolic also. So Laplace, we have sin Laplace transformation of sin hyperbolic at, and then Laplace transformation of what, cos hyperbolic at also. So let us show one. Laplace transformation of sin hyperbolic at. Okay, so hyperbolic function I think you got in trigonometric function. So this is a divided by s square minus a square. So here our s will be s will be greater than mod a. This is the condition under which it is satisfied. Similarly, cos hyperbolic at. So if it is cos hyperbolic at, then you will get s divided by s square minus a square. Now what is the difference between the last one and this one? You see, when you write cos and sin, no, the denominator you see s plus s square plus a square. So in hyperbolic, the only difference is it's minus. Okay, a divided by s square minus a square, and then s divided by s square minus s square. So again, for that now we need the Laplace transformation of e to the power at. So that's why I said that this will be this one is the most used formula. So Laplace transformation of e to the power at is what? 1 divided by s minus a. Now there is one formula for hyperbolic function. Okay, sine hyperbolic at. So I think you remember this formula, sine hx. This is e to the power x minus e to the power minus x divided by how much? 2. Okay. So this formula we are going to use here. So what is the formula then? It's in place of x we have at. So e to the power at minus at divided by how much? 2. Okay, divided by 2. This formula we have to use. Now here half is constant, and then we can separate it. One is Laplace transformation of e to the power at. Then 1 minute. Okay, so one will be Laplace transformation of e to the power at, and then second one is Laplace transformation of e to the power minus at. So half into this we can write 1 by s minus a minus. Now see here minus is there, no? So what we can write? 1 by s minus minus plus a. Just take LCM, you will get the answer. So after taking LCM, it is s plus a. So it will be your twice a divided by s plus s minus. So s square minus s square. So 2 cancel, a divided by s square minus s square. Okay. Similarly, you will prove for the Laplace transformation of cos hyperbolic at. Okay, the formula will be a little bit different. Otherwise, you just try it at home. Do yourself. It will be plus. Okay, e to the power minus at divided by how much? 2. Other things are same. Okay, so I hope this one you can do by yourself. And then one last very important property. This is 6, no? Number 6, I guess, yeah. So Laplace transformation of e to the power at, and then what? T to the power n. If it is like that, no, then we have to write like this: n factorial divided by s minus a to the power n plus 1. So this one you can relate with this particular transformation. Laplace, what is Laplace transformation t to the power n? N factorial divided by what? S to the power n plus 1. You see, similar type. But again, what is Laplace transformation of e to the power at? Is 1 by s minus a. So this one is nothing but the combination of formula 3 and formula 4, because both e to the power at and t to the power n is there. So I'll prove it. So we have that Laplace transformation of t to the power n is how much? N factorial divided by what? It is s to the power n plus 1. Now if it is like that, you see, e to the power at, then t to the power n. So the formula is what? 0 to infinity e to the power minus st. Before that you write like this. Okay, e to the power minus st, and then in place of f of t you are going to write this now, e to the power how much? E to the power at, t to the power n, and then what? dt. So 0 to infinity, these two terms we can write s minus a t, t to the power n dt. So do you remember what we can write here? There is one property, no? This property you can write f of s minus a. So I will get this in the previous lecture in change of scale, because in place of s what we have? S minus a here. So go and watch the previous lecture, then you'll surely understand. This you can write f of s minus a. Now see, this one is f of s here. If this is f of s, then what is f of s minus a? So it will be n factorial divided by c. If it is s, the formula is n factorial by s to the power n plus 1. Now in place of s, what we have? S minus a. So just you simply write s minus a to the power n plus 1. Okay, so in the same way, you see, if we write one more, suppose a Laplace transformation of e to the power at and then cos bt. So for cos, what is the formula? For cos, the formula is s divided by what? S square minus, not minus, plus b square, right? This is the formula for cos bt. But since e to the power 8 is there, so see, if it is only one function, then s. But if it is one more, e will come, no? Then you can, what you can write, s minus a by change of scale property. So here also, if it is cos, then the formula is s divided by s square plus b square. But with this, what we have, e to the power 80. So now this will be modified to s minus a, and this one we have to write, in this term we have to write s minus a whole square. Now you will see many use of these two, 7 and 8. So just you have to remember, if e to the power 80 is there, then in place of f of s, okay, in place of f of x, we have to write f of s minus a. So if it is plus, suppose it is e to the power minus 80. Suppose Laplace transformation of e to the power minus 80, then cos bt. Then this will be what? Now this is minus minus plus s minus a, and then what? S plus a whole square plus b square. Okay. So these are the few properties that we have to use in almost all the problems. Okay. So I hope all the standard forms and their proofs are very much clear to all of you. So thank you for watching the video till now. So kindly subscribe and share with your friends, so that the others also get some benefit from this lecture, and I also feel motivated when you share the video. Thank you very much for watching.